Okay, so this is notes 4.7, L'Hopital's rule. It says, recall when evaluating limits, first try direct substitution. So remember when we learned about limits in Unit 1, we said that the easiest way to solve is to always try to plug in the number first. So that's what we're going to do. So this is the limit as x approaches 3. So I'm going to do 2 times 3 minus 5 over 3, which gives me 6 minus 5 over 3, which is negative 1/3 or positive 1/3? Positive 1/3, right? 6 minus 5 is 1 over 3, positive 1/3. Okay, these were the easy limits where if we were to plug in the number, we're able to find our limit. Versus the other type of limits we learned about is that if we were to plug in this number, so as x approaches 2, what would happen to the numerator and the denominator? It would be 0. It would be 0 over 0, which would give us something that's undefined. So instead, what should we do to the numerator? Factor it. And what would be the factors here?
X minus 2, x minus 5.
Yes, x minus 2, x minus 5 over x minus 2. And then from here, we're looking to see if anything cancels. So we see the x minus 2 cancels, and what does that tell us about the graph? There's a hole at x equals 2. So that means we now can plug in 2 into whatever is left over. So we have x minus 5, which is 2 minus 5, which gives us negative 3. Okay. Now we learn derivatives, which means we now have access to I always want to say hospital. It's not hospital. L'Hopital's rule. Okay. So it says, suppose f of a equals 0 and g of a equals 0, then the limit as x approaches 0 of f of x over g of x is equal to 0 over 0 or infinity over infinity. So what this means is if we were to do direct substitution and we get 0 over 0 or infinity over infinity, then we can use this rule. And the rule states that the limit as x approaches 0 of f of x over g of x is equal to the limit as x approaches 0 of f prime of x over g prime of x. So we can take the derivative of the numerator and the derivative of the denominator, and hopefully once we take those derivatives and do direct substitution, we're able to get the answer to our limit. So this gets rid of the need for factoring to simplify. So I know some of you are still struggling a little bit with the factoring part. Now, as long as you guys got derivatives down, you should be able to solve the limits. Okay. So our first step is to make sure we get 0 over 0 or infinity over infinity. So I'm going to first do direct substitution. So the limit as x approaches 2 of x minus 2 is equal to 2 minus 2, which is 0. So the numerator checks out. Then I check the denominator. So the limit as x approaches 2 of 3x cubed minus 6x squared plus x minus 2. And then I plug in 2 for all the x values. And then just trust me, this equals 0. Or you could plug it all into Desmos if you wanted. Okay. So since we got 0 over 0, we can say by L'Hopital's rule. The limit as x approaches 2 means we can take the derivative of the top and the bottom. So what's the derivative of the numerator? 1. And what's the derivative of the denominator? Perfect. So 9x squared minus 12x plus 1. So now if we plug in 2, we should get an answer. So 1 over 9 times 2 squared minus 12 times 2 plus 1, okay, gives us 1 over 13. So 1/13 is our answer. Remember, we shouldn't have phones out until 4:20. Still can't have phones out. Write it down. Where's your notes? Then write it down. Yes.
How did the bottom, like the limit at 9 x?
How did I get this part right here? That is the derivative of this.
Oh,
And then I just plugged in 2.
okay. Yeah. Now the derivative is 1.
Okay. And I'm recording all this right now, so you'll be able to re-listen to all your beautiful voices. Okay. Okay, so let's look at the next one. Okay, so now we have the limit as x approaches 0 of sine of 6x over x. Okay, so what's our first step?
See if they equal 0.
See if they equal 0. So the limit as x approaches 0 of sine of 6 times 0 gives us sine of 0, which is 0. And then limit as x approaches 0 of x is equal to 0 as well. Okay, so now that we know that we can use L'Hopital's rule, what are we doing for each part? The derivative. Okay, so the limit as x approaches 0. And then what's the derivative of sine of 6x? 6 cosine of 6x because of the chain rule. Right? You have to take the derivative of sine, and then you have to take the derivative of 6x in the parentheses. Okay, over, what's the derivative of x? 1. So now let's plug in 0 and see what we get. So 6 cosine of 0 is equal to 6, because what's cosine of 0? 1. Okay, let's look at the next one. Okay, what's our first step? See if they equal 0. So the limit as x approaches 0 of 1 minus cosine of 0 is equal to 1 minus, what's cosine of 0? 1. So that gives us 0. And then the limit as x approaches 0 of x squared also gives us 0. So you would say by L'Hopital's rule, what are we going to do for each one? Take the derivative. Good. So the limit as x approaches 0. And then what's the derivative of 1 minus cosine x? Sine x. Okay. And then what's the derivative of x squared? 2x. Okay. Before we continue, though, what is going to happen if I plug in this 0? I'm still going to have that 0 on the bottom, okay, and the 0 on the top. So that means I'm going to do the rule again. So I'm going to take the derivative again. Yep, we're going to do it again. And if we need to, we're going to do it a third time. Okay? So go ahead and take the limit again. What's the limit, or not the limit, sorry, the derivative of sine x? Cosine x. And what's the derivative of 2x? 2. Now if we plug in 0, cosine of 0 is 1, so we have our answer of 1/2. Okay, there's one other way we could have done this without using L'Hopital's rule again. Anyone recall the properties of limits from Unit 1? And it has something to do with this right here. Good. Sine x over x is 1 only when x is approaching 0. So this is a rule. So the limit as x approaches 0 of sine x over x is equal to 1. Which means it would have simplified to 1/2 at that point if we would have remembered the rule. Okay. Well, you learned it back in Unit 1, but that's been a while, right? So my hint to you is just keep doing L'Hopital's rule until you get the answer. Because you guys are all very good at taking the derivative.
Yes.
Okay. Any questions so far? Okay. Okay, now number 5, notice that this is as x approaches infinity. So instead of checking 0 over 0, what do you think we're going to end up getting? Infinity over infinity. So I'm going to do the limit as x approaches infinity of 2x squared. And I know that that is going to approach infinity. Please don't plug in infinity for x. Okay? They don't like when you do that on the AP exam because infinity is not a number to plug in. Okay? And then we have limit as x approaches infinity of e to the 2x, which is also going to approach infinity. So that means we can use what rule? L'Hopital's. Okay, and so let's go ahead and use that rule and take the derivative of the top and the bottom. So as x approaches infinity, what's the derivative of the top? 4x. The derivative of the bottom? 2e to the 2x. Okay, well, if we do this, we're still not getting an exact answer here, so let's go ahead and do it one more time. Okay, so the limit as x approaches infinity, what's the derivative of the top? 4. What's the derivative of the bottom? 4e to the 2x. Okay. What's going to keep happening here if we say we take the derivative one more time? It's going to be 0. So let's do that. Let's take that derivative one more time. So the limit as x approaches infinity, what's the derivative of 4? 0. What's the derivative of 4e to the 2x? 8e to the 2x. What's 0 divided by anything? 0. So our answer is 0. Okay. Or we could approach this a different way. Okay. If we were to, let's say, not use L'Hopital's rule at all, and we were to look at the very beginning where we plugged in infinity, would you agree that this fraction would be bottom heavy? And why would it be bottom heavy?
Because the variable in the power.
Good, because it's an exponential function, which means exponential functions grow at a faster rate than what functions on the numerator? A quadratic. So they grow faster, which makes it bottom heavy. When our fractions are bottom heavy, they're going to approach 0. Okay, so two different ways to look at that. Okay, especially since x is approaching infinity. Yes?
What happened if it was top heavy?
That's a great question. What would happen if it was top heavy? It would approach positive infinity. It would approach positive infinity. And we can make a note of that. Top heavy would approach positive infinity. And that's because of our two equations here, and then also x is approaching positive infinity. Okay. So at the bottom of these notes in big bold writing, what does it say? It's not the quotient rule. L'Hopital's rule is not the quotient rule. Okay, what that means is if we were to look at this equation, and notice that this equation is similar to what problem? Number 3 that we did. Notice in number 3 was the limit, but here it's asking us to take the derivative. So we're going to get two different answers. We're not going to get 6 like we did in number 3. Instead, we're going to have to use the quotient rule. And the quotient rule is f prime g minus fg prime all over g squared. So let's go ahead and use that quotient rule and take the derivative of sine 6x over x. So what would be the derivative of sine of 6x? 6 cosine 6x. And then we multiply it by g, so there's an extra x, minus sine of 6x times the derivative of g, which is 1 all over x squared. And I would just simplify this by getting rid of this 1, right? We don't need that 1 there. And then where would I write this x? By the 6. Good. So then this is 6x cosine 6x minus sine of 6x over x squared. And that would be our answer for the derivative of that function. And this is just showing you that we only use L'Hopital's rule for limits.